All right, class, welcome to Math 2020, Section 8.3, the area of circles and sectors. So 8.3. Area of circles and sectors. Okay, so we're going to go through the handout, and I'll go ahead and explain what they're talking about, and you can kind of fill in the handout as you watch this video. Feel free to pause at points in the video where you can try and do things on your own and then press play to see how they work out. So number one, we're going to have three methods. So part A. We're having three methods to find the area of a circle. And you can read this in your section, in your book, if you want a different perspective on these. But the first method is called the pizza method. Okay, because we're going to slice up the circle like a pizza. Now, the approach to finding the area of a circle is similar to finding the area of other two-dimensional figures. Okay, so we have a circle, and we have to slice it up into parts here. Okay, so we have a circle sliced up like a pizza. And we have these 8 slices that we're going to do. And just like, again, as I was saying, just like the way we found the area of other two-dimensional shapes, we take something that we want to find the area of, transform it into something that we know the area of already, and then relate that back to our original figure before the transformation. So we're going to take this pizza, this circle, and we're going to transform it into a parallelogram in the same way as designed in the handout. And then we'll find the area of this parallelogram, and then it will be the same as the area of the circle, because we're not changing anything here as far as shape or anything like that. We're not doubling, we're not adding on parts, we're not cutting off parts. We just cut it up and then arrange it into a parallelogram. Now I'm taking each of these slices, and I'm going to take a slice and put it like this, take a slice and put it like that, and continue on for 8 slices. 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so there's a couple lines here I'll fix. Okay, there we go. We have our parallelogram. So if everybody, we're going to pretend that this is a parallelogram. So I'm going to draw it in blue. Let me do that back. Draw it in blue. Draw this in blue. Okay, so we have a parallelogram. Now this parallelogram has a base and a height. And so I'm going to do the base here. And then I'm going to label the height here. So distance from the bottom to the top at a right angle. Okay, and that's the height of my parallelogram. So we're going to find the area of this parallelogram, and then I'm going to see how that relates to the area of the circle. So there's my base, my height. So the area of the parallelogram is equal to the base of the parallelogram times the height of the parallelogram. Okay, and so what we're going to do is we're going to relate the base and height of the parallelogram to the circle itself. Now on the circle, we can label a few things here. We can label this right here as the radius, and that's the key part of the circle because every point on the circle is the same distance, or the distance of the radius from the center. Okay, so that's the radius. And then we can also measure, like we did in last section, the circumference. So the circumference is the distance all the way around the circle. Okay. So we can measure the circumference and the radius. And so where does that lie in our parallelogram? Okay. Well, we're going to look at the base of the parallelogram here. This is the base. And notice that it is consisting of these curved parts. Okay, curved parts. And now these curved parts are just those on the bottom, which is actually 4 of the slices curved parts. So we can kind of see here that I'm going to take 4 of the slices curved parts, and I'll highlight them on my figure. Okay, and so notice that all four curved parts go halfway around the circumference, halfway around the edge. So the base of this parallelogram is half the circumference, because the other half is on top, right here, 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 here. Okay, so we're going to do the area of a circle. Is equal to, now the base, which is the base of the parallelogram, half the circumference of the circle, times the height of the parallelogram. So let's take a look at the height. The height of the parallelogram is here, distance from the bottom to the top. Now, in my circle pizza slice, where is that at? The height it goes right through the middle of one of those. So the radius, notice that goes through the middle of that one. It's the same length as this one, which I've highlighted as a radius. So according to my formula, the radius is the same as the height of the parallelogram. Okay, so the circumference, we want to rewrite this a little bit so we can combine r's together. So I'm rewriting the circumference in terms of r. Circumference is 2 pi r. The half and the 2 will simplify to 1. The r and the r will come together and become r squared. So the formula for the area of a circle is pi r squared. Okay, pi r squared. All right, now, so some of you might not be exactly comfortable with the way that I've drawn this parallelogram. What do you say about these spaces here? These spaces here are not part of the parallelogram. I'm actually overcounting a little bit, right? Well, one may think that, but there's a very helpful thing called calculus that can help you, the idea of a limit. Let's say that I draw my circle, and I divide it into not just 8 pieces, but 16. Draw each of my pieces in half, 16 pieces. So I'm going to open this up, okay, into the slices, and notice how thin they are. So we got like little ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, 16 pieces. Now this is not the best drawing, but go ahead and let's take a look at our parallelogram now. So I'm outlining the parallelogram in blue. Okay, and again we're going to take a look at the gaps that are in there. Notice how big the gaps are now. When we have 16 pieces approximate the parallelogram, if we divide the circle up to that many pieces, then notice that the gaps are smaller. Okay, notice smaller gaps here. Now if we take a pizza and we divide it into infinitely many pieces, how big are those pieces going to be now? Okay. If I divide it into infinitely many pieces, they will actually fill up the parallelogram perfectly in this way. So this is the size of the pieces. Okay, I'm fitting them all in there. Because they're pretty much lines. They actually become lines, infinite, with no width but length. Many slices become lines. Okay, and they become not lines but segments. Okay, and then they will actually fill up the parallelogram to become a complete parallelogram. So this method works not only geometrically but numerically as well. Okay, area of a circle, pi r squared. In this next video, we have 2 more methods. We're going to do number 2, the braided, or part, so 1 part B. We're going to do what's called the braided rug method. Let's see how we like this one. So the braided rug is a, oops, sorry about that. The braided rug is a bunch of braids that are connected together, going smaller and smaller from the outside to the center. Okay, so they're like cords that are just tied together, so they make concentric circles. One circle into the other, so the lengths get smaller and smaller and smaller. Now, if you were to cut the braided rug here and open it up, we would have a triangle. Oops. Make it as tall as this one here, so we have a triangle. Okay, so it's tall. Okay, a little bit more to scale here, but not perfect. We're cutting and opening up, and what we have is a triangle that has a bunch of rows on it. Okay, with the braids. Now these are segments because they're segmented braids, so I'm going to draw in the segments here. Okay, and we're going to find the area of this triangle. So I haven't taken any area away from this circle braided rug. I haven't added any. So the circle area of the triangle is the same as the area of the circle. Okay, so let's go ahead and label these parts here. The triangle, the area of the triangle, oops, let's just go like this, area of T, is equal to the base of the triangle times the height of it. Oops. The area formula for a triangle, that is, 1/2 the base of the triangle times the height of the triangle. Okay, so we need to identify where the base of the triangle is, which is right here, base triangle. Then the height is this one here, because it's base at the right angle. So here's base, and height. Okay, and then that distance right there is height of triangle. Now the formula is 1/2 base times height. Now the base of this triangle, let's take a look here, and we're going to connect it to, this is the base right here. We can connect it to the circle, which is the base. Notice that the base is consisting of the longest chord, and on my circle model, the longest chord is the one that goes around the outside. Okay, so the base actually happens to be the same as the circumference of the circle. Let's take a look at the height. The height is this distance here. Okay, this is the height. Now, going back over to here, you can see that the height is right here. Now, what's that distance? Well, that distance happens to be the radius. Okay, so going back to my formula, the area of the circle is equal to 1/2 the base of the triangle, which is the same as the circumference, times the height of the triangle, which is the same as the radius. Okay, so we have 1/2 CR again. So this is the rest of this is similar to what we did in the part A. So the circumference we're going to rewrite as 2 pi r, so we can combine it with this r. And then we're going to do 1/2 of 2, that cancels. You just get pi, these will go with that one, r squared. Okay, so that's the area of a circle using braided rug method. Now part C is going to be the polygon method. Oops. The polygon method is going to be extra credit. So if you want to skip to the next video, you can go ahead and press stop. And let's get to the next video. So the polygon method, sorry about that, has, come on now. Let me try to get a better circle here. Okay. Takes the circle and it divides it up into a polygon. So it inscribes a polygon within it here. Okay. So a polygon has a certain number of sides. Okay, so this is an approximation of the area of a circle. Let's take a little side note here and say, okay, a circle that as you approximate with the 3-sided polygon is just a triangle, and it has this much gap. The polygon that is, the circle that is approximated with a square looks like this, and it has this much gap. Okay, so the number of sides equals 3 here. The number of sides equals 4 here. The number of sides equals 5 here. And let's take a look at the gap, because the area of the circle is being approximated by the area of the polygon. Okay, and then we'll do one more. The area of a hexagon try to fit all the hexagon inside here. Okay, so notice that as our numbers increase, 3, 4, 5, 6, the gap also decreases. Okay, so big gaps, even smaller gaps, and even smaller gaps. Now, what happens if n is equal to infinity? Infinite number of sides where the side length is not this big anymore, or this big, or this big, or getting smaller. It's actually gone to a point. Now, if n is equal to infinity, that means that there are no side lengths more than bigger than 1 point. And so the gaps that are here go down to 0. Okay, so this polygon method is a good method to use, and using calculus, which is the idea of a limit, notice that these are progressing, and we make the side length go down to 0, which would fit the entire circle. So for a polygon method, we need to find the area of the polygon, and it will become, when the number of sides goes to infinity, then it will become the circle. Okay, so the area of the polygon is on the area of this triangle, times the number of sides. Okay, because that means that that's how many triangles there are. See, one side here, there'll be another corresponding triangle here, and here, and here. Okay, so the area of the triangle is 1/2 base times height. So you have n triangles. Oops. 1/2 base times height times n triangles. Now the base of the triangle, let's just take this one for example, is here. Okay, base is here. And that is the circumference all the way divided by the number of sides there are. Okay, so it's like this portion here. And remember, when we get to infinity amount of sides, the sides go down to a point, and they'll actually come into this curve here. So this gap right here will disappear when we go to infinity. Okay, so the base is equal to the circumference divided by n. Height, I'm going to do here, at a right angle. Oops, let's get a better arrow there. And the height is equal to the radius. Okay, so remember that the height of the triangle goes down to here for right now, but when it goes to infinity, it'll go down to here. Okay, and be equal to the radius. So what we have here is a formula we have enough what we need to substitute. We have our base, our height, and we have n times by n. So 1/2, the base is going to be circumference over n, times the height, oops, sorry about that, times the height, which is the radius, times the number of triangles. Okay, so we're going to cancel off the number of triangles first, and then we have 1/2 CR again, which is equal to 1/2 times 2 pi r times r. Those will cancel, and we get pi r squared. Okay, so that's the polygon method. Okay, class, we've derived the formula for the area of a circle now, and those are test questions. The polygon method will be extra credit, but make sure you know how to do the pizza method and the braided rug method. In this last part of the handout, we do some exercises to help us refresh our minds about how to find the area of a circle. And let's go ahead and start with number 2, okay, on the back of the handout. We want you to find the area and the circumference of a circle with a radius of 5.4 centimeters. Radius is equal to 5.4 centimeters, and we have 3.14 for pi. So we'll back that up here. Yeah, pi is equal to 3.14. It's not actually equal, just so you guys know that pi is about that much. The number goes on forever. But we're going to take 3.14 for our approximation to pi. It's perhaps better said. Now we want you to find the area of the circle, so the area is going to be equal to pi r squared. I always write down my formula so I know what parts to look for. And pi is 3.14. The radius is 5.4 centimeters. and then I'm going to square that. So don't forget the little 2 here at the end. I do sometimes. Now when you're going to simplify this, you do need to square first before you multiply. So 5.4 squared, go to my calculator, do that. You get 29.16 centimeters squared. Okay, when I multiply that by 3.14, I get 91.56 about centimeters squared. Okay. So that's the area. So you're finding the area. The circumference is equal to 2 pi r. I'm using 2 pi r because they give me the radius. Okay, so 2 times 3.14 times the radius, which is 5.4 centimeters, is 6.28 times 5.4 centimeters, and that's going to equal 33.91 about centimeters. So these are approximately equal to, right here, both of these. Let me make that adjustment. Okay, so just a refresher on how these work. The next one is going to be finding the area of finding the radius of a circle when given the circumference and the area. Okay, so that's number 3. Okay, so we find the radius when in part A we have the circumference is equal to 176 units. We can just use U for units. Okay, so we know that the circumference is 176 units. We know that the circumference formula is 2 pi r. Okay, so and then we're going to say r is equal to 22/7. Because this is a practice with the fractional form of pi approximation. Okay, so we're going to do 176 units, substitute in our 2, or the 22/7 in for pi, and we have a r. Now r is what we're going to find, so that's why that's still a variable. So to simplify that, 176 units is equal to 44/7, so we multiply these two together, times r. Now to undo the 44/7, we need to multiply by 7/44 to both sides. Okay, this will simplify here with that, and r is going to equal 7/44 times 176 units. And when we do that on our calculator, we multiply the 176 times 7, then divide by the 44. We get that r is going to equal 28 units. Okay. Now we're going to verify that the area is going to, given the area, we're going to verify that the radius is 28 units. So the area is going to be 2464 units squared. Okay. The area formula is equal to pi r squared. That's what we learned about just now. And so 2464 units squared is the area, so it's in place for A. Pi is 22/7. The radius is going to be what? We don't know. Okay, so we'll keep that as a variable. We actually know that the radius is 28 units, but let's verify. Keep our squareds in there so we don't forget that. Now to get rid of the 22/7, I'm going to multiply by 7/22 on both sides. Okay, and so this will simplify with that. So r squared is going to equal this 2464 times 7 divided by 22. And when you do that, you get 784. Okay, and to take the square root of both sides, r is going to equal 28 units. So it indeed is 28 units. Okay, welcome back. Number 4. So number 4 is we're finding the area of a semicircle. Now a semicircle is half of a circle. Okay, and this is 7 centimeter diameter. We need to find the area of it. So the area of a whole circle is pi r squared. Okay, and that means that the area of half a circle is half pi r squared. Now r in this case is going to equal half of the diameter. R is going to equal half of 7 centimeters. Make sure that you keep track of the in the homework whether you're given the diameter or the radius. Okay, so that's going to be equal to 3.5 centimeters. Okay, so the area of the half the circle, so area half circle, is equal to 1/2 pi, and they tell us to use pi is 22/7 again. R 3.5 centimeters and squared. Okay, so let's go ahead and simplify this. This will simplify with this one by doing that as 11. So we have 11/7 times, now 3.5 squared I need to do before I multiply. So 3.5 squared, according to my calculator, says 12.25 centimeters squared. Okay. So we take this number, multiply by 11, divide by 7. And we get that the area of the half circle is 5.5. Oops. Centimeters squared. Okay. Now the last one, number 5, is the area of the shaded region. Okay. The area of the shaded region is looks like this. So I'm just going to draw a copy of it here. Circle thing part there. This right here is 120, and this right here 14 centimeters, and just this part right here 7 centimeters. Okay. So the shaded region is right here, so you shade that in. Now the area of the shaded region will take a couple of steps to do. So I'm going to write down my formula as a plan. And so I recommend that you do this as well on the homework so that you can keep things straight, and it'll also help me grade easier too. So the area of this shaded region is equal to the area of the sector subtract, well, area of the big sector that's shaded. So I'm going to go back and call this I'm going to use some colors to help. The area of the green sector, so I'm going to take this whole sector here in green. Okay, oops, try that curve again. Okay, right here. The area of this whole sector in green, and subtract off the area of the blue sector. Okay, now the blue sector is this little part that's white and will not be part of our figure. Okay. All right. So let's go ahead and try and figure out the area of a green sector. The area of the green sector is a part of the area of a whole circle. So we're finding the area of whole circle as pi r squared, which is equal to pi as 22/7 times the radius, which is 14 centimeters squared. I have to square first before you do the pi. 14 times 14 is 196. Okay. I take my 196, multiply by 22, divide by 7, my calculator, and I get, oh, sorry about that. And I get 616 centimeters squared. Okay, so that's the area of the whole circle. Go back down to my, so you can see my picture. Okay, the area of the whole circle. Now the area of the sector is going to be whatever portion of the whole circle that this is. Now the key to that is going to be here with the 120 degrees. Okay, so the whole circle is 360 degrees, but I only want 120 degrees of that. Okay, so I'm going to set up a proportion. So the area of green sector is equal to is the area of the green sector in relation to the circle. So we need to do a proportion, which is two fractions equal to each other. Area of whole circle. Whoops, let's pick up that a little bit. Is equal to the 120 degrees over the whole circle, which is 360 degrees. Okay. Now we know that the area of the whole circle is 616. The area of the green sector divided by 616 centimeters squared is equal to 120 over 360 is just a third. Okay, so we have area of green sector times 3 equals 616 centimeters squared times 1. Times 1. And so when we find that, we need to divide by 3 for both sides, and then the area of the green sector is equal to 616 divided by 3, which my calculator is 205.3. 3 repeating goes on forever. Okay. Now that's the area of the green sector. So going back to our plan, we have the green sector subtract the area of the blue sector. So now the area of the blue sector, or the white part, is the area of the whole circle, and whole small circle. Okay, which was equal to pi r squared. Now the radius of the small section is going to be 7 centimeters. Okay, and so we have pi the same as 22 sevenths. So that's equal to 22 sevenths times 7 centimeters quantity squared. Okay, 22 sevenths times 49 centimeters squared. That's going to equal 154 centimeters squared. Okay. Now the area of the blue sector is the area of the whole small circle, and we're going to set up a proportion. Area of blue sector over area of circle. That's equal to the same proportion here of 120 over 360. Okay, the angle, central angle is still the same. And so we have area of the blue sector divided by 154 centimeters squared is equal to 1/3. So area of blue sector times 3 is equal to 154 centimeters squared times 1. Okay, we divide by 3 on both sides, and then the area of the blue sector is equal to 154 divided by 3. $51 and 315. Ack. No, go back. Hold on a minute. Get back to here. I'll erase that mark I did. Okay, it goes on forever. Okay, so the area, so let's go back to our plan. The area of the shaded part here and is area of green sector minus area of blue sector. So we calculated both of those down here. Okay, so the area of the green sector minus the area of the blue sector is equal to 205.33 repeating centimeters squared. Subtract 51.33 repeating centimeters squared. When you subtract those, you'll get 154 centimeters squared. Okay, so there's probably some other ways of doing that one, but that's one way, and I think I did another way in the handout solution, so you can check that out. But anyway, enjoy your homework, and we'll go ahead and stop this video. Okay, class, what I'm going to do now is give you a bonus video on the homework from a homework problem. We'll do number 2 in the homework. Now, I want to model this homework problem for you so that you can do these similarly to help keep track of your work and then also help me grade. Okay, so the idea of this problem is that 2 sprinklers in the Washington's backyard water up these white areas of the backyard. What is the area of the shaded portion that does not get watered? Okay, we're going to take 3.14 equal to pi, and we're going to give our answer correct to 2 decimal places. This figure I'm going to draw out now. Consists of two parts of a circle, 2 quadrants they call it. So that means 2 quarter circles here. So it's not quite to scale, but we're going to pretend it is. Okay, and then the shaded portion is just the rest of it right here. Okay, so that's shaded portion. We need to find out what that is. Find out what the shaded part is. Okay, so what we're going to do is that we're going to make a plan. So the area of shaded part is equal to the area. Okay, so we're going to outline our plan here with blue. So we have the area of the shaded part here, or the area of the whole rectangle here in blue. And I'm going to subtract off the area of these quarter circles. Okay. And here's another one right here. Okay, so area of the shaded part is area of rectangle. Subtract area of 2 quarter circles. Okay, which is actually going to be the area of a half circle. Oops, because 2 quarters are a half. Okay, now the only dimensions that we get because what we're going to do is we're going to find the area of a rectangle first. So let's do that. Let's write this down. The area of the rectangle is equal to length times width. Now the length and width we don't have. So this is the length right here, or the width, whatever you want to call it, and we're going to pretend that's the width. Okay, and so we know that the width is equal to 8 meters. Okay, this whole thing right here. The length we don't know, but we do know that this is a quarter circle, and so that means that this distance here is the same as this one here. So this part is also 8 meters, and this part is the same kind of circle. That's also 8 meters. So length we can deduce as 16 meters. Okay. So our area of our rectangle is length times width, which we know is equal to 16 meters times 8 meters. And that's going to equal 128 meters squared. Okay. Now we have that one taken care of. We need to find the area of 2 quarter circles or a half circle. So I'm going to label this section as area of half circle. Okay, and the area of a half circle is equal to a half of the area of the circle, pi r squared, half of pi r squared. Now pi we're going to take as 3.14, so we have half of 3.14. The radius of these is 8 meters. Square that, so don't forget to square it, because sometimes I forget to do that. Okay. And when I do that, I take half of 3.14 is 1.52 times 64 meters squared. When you do that, you get 100.48 meters squared. All right, so the shaded area, which is what we're going for, is area of rectangle. Subtract off area of the 2 quarter circles. So shaded area is equal to the 128, area of the rectangle, subtract off the 100.48 meters squared. Type that into your calculator, or you can do it in your head. Get 27.52 meters squared. Okay, so it's good to circle or box your answer. And that's the model for the homework. So let me know if you have any questions. Enjoy.